Welcome everyone. My name is Ralph, this is Joe. We'll go through what the lab looks like, how we put it together, the kind of things we're going to cover today. And then, I'm in the wrong place already. I'm supposed to be up here. Once we do that, we'll have you actually log in and start your lab. We want to wait as long as we can because we have a limited amount of time that your lab is going to be able to run. And we actually have more time here so that we can talk to you about the lab. So 2425-02 is what we will look for. We'll let you know when to go ahead and click the start button. If you have already, not a big deal. We'll work through it. So yeah, where's my clicker? There it is. So again, 2425-02, advanced topics in NSX. We cover mostly routing and some of the advanced functionality we'll talk about today. Actually, we'll go through it in a slide here. My name is Ralph Stoker. I've worked with several of the people that you see around you that are all kind of part of the team. And we have put together the steps, built out this lab, and we're going to kind of walk you through that process. So obviously, introduction, Ralph Stoker. Do you want to introduce yourself, Joe?
Sure. Hi, Joe Collon. I'm a network and security VCN, we call it now, SE pre-sales engineer based out of San Diego. So I've worked with these folks, the core of the NSX hands-on lab team. We've been together, about 3 years now, working on the labs together. Hope you guys enjoy the session.
Yeah. I forgot to mention what I actually do. I'm a network and security technical adoption manager. It's a mouthful. We call ourselves NSTAMs. So we typically work directly with customers and help you with all of those things after you've bought the product to implement and make sure that the product is as effective as it can be in your environment. So as Joe was mentioning, he's been with VMware for quite a while and with HOL for almost as long. He does a lot of fun stuff like I do, outdoors, snowboarding. I'm not that cool. I can't do that. I'd break my neck. But yeah, that's... I like to just mess around with things, whether it's car projects or home improvement projects. That's kind of why I have this job. I like to break things and fix them. And we do a lot of that here as well. All right, so building the lab. What you're going to see today, and actually hopefully you've been out here and have had a chance to run through other labs as well, but you'll notice that it looks like a real environment, and in many ways it is. We have different components at different levels of, everyone's familiar with Inception, the movie. So we have L1 VMs that run as actual virtual machines on a physical host. And then we have L2 VMs that run just below that on ESXi hypervisors that are already virtualized themselves. And Joe will go through a little bit of that on one of the next slides. So people like Joe and John Brandt over there and Kevin kind of in the back, they put together the pod. They're the ones that are going to build out that foundation. And for this, the 2425 has one single foundation, then we can build multiple labs off of that. So they set the foundation, and then people like myself and Jason and Lynn, we put together the manuals and the processes and all the things that you can do with that lab. And then there's, as you can imagine, a lot of testing. I messed up a lot, and luckily Lynn and Lauren wasn't able to be here, but they found all my mistakes, so hopefully you don't have to find any either. If you do, just poke us. We'll fix it. Anything to add? Okay.
So in terms of the process for building the labs, each one of the instances takes quite a bit of resources. So at the start of the hands-on lab season or development cycle, we typically go through and we have to figure out how many hypervisors, how many edge nodes, how much RAM are the different NSX managers and things like that going to require. And we put together a spreadsheet because if you think about it, each of the pods that you're using today, it's 3 terabytes of storage, give or take. We're using, I think it's actually a lot more than 40 gigs of RAM and a lot of vCPUs, 83 vCPUs. And if you think about it during the show, we've got hundreds or thousands of these labs that are getting spun up. So the amount of drain that we're putting on the resources that we have available is pretty high. So we go through kind of weighing things out. Sometimes we scale things down. We've got one NSX manager in your pod instead of the 3 that we'd normally recommend. Sometimes we'll bump the RAM down a little bit and see if things will be stable. So it's kind of, to be honest, it's put together with sort of bubblegum and baling wire under the hood just to try and make sure that we can fit as many of these in as we can during lab week. So hope you guys enjoy them. And once VMworld is over, we typically Explore is over, we publish them to the public website, the HOL.VMware.com, and you can take them for free the rest of the year.
So Joe made a very good point there. Don't judge us for how non-best practice our environment is here. We really have to skimp things down because we are running a lot of copies. Some of these labs have to have 200 copies running at one time in the assorted clouds for you guys, so that you don't have to sit and wait for 30 minutes in some cases for one of these to spin up. From the time you hit power until everything's actually ready can be 30 minutes. But we want you to be able to sit down and just go. So there are a lot of resources being used, and you may have seen it as soon as you walk in is the command center. That shows all of the resources that are used across all of the different clouds we have for literally all the labs that are available here today. So today, we're going to focus on a few of the more foundational modules. There are 6 total modules to this lab, and if you'd like, you can work through all of these modules at the self-paced. We're going to start off with the first module. That's like I mentioned, a foundation of this. Dynamic routing, BGP, ECMP, those sorts of things. Multicast and VRF, that's virtual routing forwarding. So those are kind of the advanced topics that you're most likely going to use every day. And then we're going to get into some of the other capabilities that have either recently been added to NSX, or they've been there for a little while and they've been improved. So we wanted to show some of the things that are getting even better. So one of those recently added functionalities would be multi-tenancy. We now have the ability to create projects in NSX. With that, you'll be able to separate your tenants or your customers' resources, and yet still have the same foundation, the same infrastructure at the core for all of those resources to flow through. We're also going to touch on operations. How do you troubleshoot the environment? How do you make sure the environment is healthy? And if we have time, I would love to touch on either Module 5 or Module 6. I don't think we'll have enough time to do all of it. So we'll kind of feel it out. If we get there, see what you guys are like, which direction you want to go, and we'll go from there.
And I'll jump in here and just kind of add on. We love kind of interactive sessions when you guys are asking questions and things like that. So if there's anything that comes up during the course of the session, please raise your hand. I've got a mic. I can walk around and we can kind of cover anything you guys want to cover. Yeah, so as we mentioned, some of this is physical, running on physical hosts. That's what this is showing you. There are some physical hosts, and you can't really see that. I forgot to change the color. But the virtual nodes that run on top of a host are communicating with the same tunnel endpoint, TEP, that's on the physical nodes. And in this case, we also have several nested ESXi hosts. They're all in the same TEP network. They all communicate with each other, even though some of them are nested below. Not something you do in your own environment, but we want to try to simulate as much of a real-world scenario as we can with the constrained resources we have. So this is a logical view of one of the sites. One thing that we didn't quite mention earlier is Module 6 is about federation. That's about bringing together potentially multiple instances, whether in the same location, just across multiple environments within one location, or disparate locations worldwide. Federation can help bring those resources together. So this is showing Site A, and it's essentially mirrored for Site B, just with different networks. So you'll see that there is a vPod router at the core with an admin desktop that's attached directly to that over a VLAN in this environment. And then below that, we start with a single T0 gateway that is attached to a couple of segments for you to see what configurations look like. We're going to modify some of those segments in some of these labs. And again, this is also shared across the O1 lab.
So some of these things we may not touch on today, or you might not see in the O2 lab. It's because they were used somewhere that they exist. So what will we likely miss? We're going to bypass the VPN lab for today's experience. And as I mentioned, hopefully we have time to do one of the two labs, either the automation or the federation lab. But it really depends on how quickly we can get through things, because there are a lot of tasks here. Some of these, even though they're relatively simple in concept, there are a lot of steps to implement it. So we'll do as much as we can, and if you have questions, if we didn't get to something, just grab one of us, any of us. We all know how to do this stuff. So if you find us out on the floor, we're happy to help you through it. Also, these are all the networking and security labs that we actually have. You'll notice that NSX networking and security there on the left-hand side. So fundamentals is 01, advanced, that's what you're in now. But we also have the NSX Plus lab. For those that may recall, North Star, Project North Star is what that was announced as a year or two ago. That's now a product with NSX Plus. The NSX Security Lab, there's some really cool functionality that took Kevin and Jason a lot of effort to get those things up and running. NSX Application Platform is a very cool thing to try out. So if you have a chance to run through that, highly recommend it. We also have ARIA Operations for Network. That used to be called VRNI, vRealize Network Insight. Super helpful. Obviously, Edge Services with SD-WAN and SASE, great labs. And NSX ALB, that was the Avi acquisition. It's NSX Advanced Load Balancer. Those are fantastic. I love that. That's my favorite product. Even though I'm an NSX guy, that's my favorite. All right. I don't think I was supposed to show this slide just yet, but that's for the end. We can go ahead and launch your lab if you haven't done so already. Okay, so if you haven't yet enrolled in your lab, this is where you should be. And at the top, you'll see you have a search bar. Our lab is already showing up. It's already filtered for me. You see it here, 2425-02. We will go ahead and click Enroll, and then start this lab. So it takes just a moment. As I mentioned, if we were to have just spun this up from scratch right now, this would take about 20 minutes for us to actually be to a functional level. Some things come online a little quicker. I'm sure you guys are very familiar with how long it might take vCenter to load or NSX Manager to load. While the machine itself boots in 30 seconds, it takes 5 to 10 minutes for the web services to engage. So we're going to try to make this as big as possible, so that we can see well enough. All right. So hopefully you've had a chance to explore our labs, but over on the right-hand side is going to be the lab manual, and we can click through there. We're going to do the first lab. Most of this is all in preparation. Your lab should be good to go, so we can kind of move through some of those a little quicker. First, we're going to start, like I mentioned, with the dynamic routing and ECMP. So we're going to configure the T0 gateway for equal cost multipathing, ECMP. Allow for multiple uplinks, and it can just decide where to send the traffic. It doesn't have to force traffic through one link or another. Allows you to take advantage of more throughput for your T0. So we're going to launch the browser and log into NSX. Click Region A and NSX Manager 01A. Password should be populated for you already. We can go ahead and get into the system. And as Joe mentioned, if you guys have any questions, we're kind of in the beginning, but if you have anything, feel free to raise your hand. I'd rather not read instructions to you. I'd rather this be interactive, have questions, make it what you need it to be. All right, so we are going to go to networking, and then on the left-hand side, T0 gateways, and you'll see that we have T0 GW01. We're going to edit that guy. Actually, I think in this first place we're just looking. Yeah, my bad. I get ahead of myself. I've done this lab probably 150 times in the last 2 weeks, so we're going to expand interfaces to take a look. You'll see a tiny little number 1. I'm not, yeah, that's really blurry. I apologize. But down here under interfaces, you'll see a number 1. That's where you're going to want to click. That will show you the existing interface that's assigned to this T0. We can then expand that and take a look at the configuration. Things to note in here, we have it connected to a segment called T0 Uplink 01. And this is attached to Edge Node 01A. So we have actually assigned this physical uplink to one of the edge nodes that are deployed. All right, we can close out of that, and we're going to take a look at the BGP configuration. So scroll down just a little bit further, and you can expand BGP. And down here, you'll find another number 1, way down there, for BGP neighbors. And here, we can see the details of the existing BGP neighbor and the source address that we are actually connecting from. So again, we're just taking a look here. We can see the configuration. Currently, we do not have BFD, bidirectional forwarding detection, enabled. We will be configuring that as part of the lab, but we're just kind of taking a look around right now. So the next step on page number 16 here, we can take a look at the topology. So on the left-hand column, you'll notice network topology is an option, that way up here. This is a fantastic overall view of how the environment is configured. And as you go through this lab, right now we have that single T0. We're going to add more T0s. We're going to add more T1s. We are going to add more infrastructure to this, new logical segments. And it all builds out in here in a very logical flow. You'll see how things are connected back. Everything in this environment is clickable to drill down even further. Like here, this is showing that this is an active T0. So that's some configuration information. This particular segment is LSNY Web. So that's the New York Web segment. So we actually refer back to this network topology pane quite frequently throughout this lab, and I do in my real life as well, because it's a nice quick way to see how things are connected. All right, so now we can go down here, pop open the terminal. And I like to maximize this right away just because we do have a relatively low screen resolution based on the nature of what we have going here. So things wrap around if you don't maximize your terminal, and it just makes it messy to read. So we are going to do a trace path -n to 172.16.10.11. I don't know how to type. It's 192.16, not 168. Much better. See, that's what I expected. So what we're seeing here are the different hops along the way. The .1 address is the vPod router, and the .3 address is our T0. Notice how we do not see the gateway address of .1. That's just the nature of the logical routing within NSX. We don't have to show that path, that bounce. All right, so now we're going to actually modify that T0. How I mentioned earlier that we're going to add an interface. So if we go back to the Firefox browser and then click T0 gateways in the left-hand column, we can click those 3 dots beside T0 GW01 and go to Edit. We can scroll down to Interfaces, click on that number 1 again, and now we're in an Edit interface. So on the next page, we'll have some details for Add interface. And then we'll have the details here that we need to configure. So we are going to set this up as 192.1, EN2-uplink1 with an IP address of 192.168.120.4. Oh, I almost forgot, /24. If you don't put the mask on the end of that, it will yell at you. It's fine. It'll tell you what you need to do, and you can go back and modify that. And then we want to attach this to T0 uplink 1. So as I mentioned previously, the uplinks have to be attached to a specific edge node. Notice how edge 01 is no longer an option here. We already have an uplink for this T0 on that edge, so we want to attach this to O2. So select edge O2, and then scroll down just a touch so the save button is visible, and click save. So we've now added our second interface to the T0, but the T0 doesn't know what to do with it yet. We haven't told it to utilize that interface. So in the next step, we are going to add that secondary uplink to the BGP source IPs. So when you click close out of the interfaces pane, you can expand BGP and click the number 1 by BGP neighbors, just like we did before. And we are going to edit this existing neighbor. So this goes back to the way this lab is built is to be as small and simple as we possibly can. Normally you would probably be adding to a second neighbor instead of to the existing, but this one we're peering with the same neighbor just to keep things as concise as possible. So what we want to do is we want to add that new address, that .4 address, in here to the sources. And then we are going to click save and close editing. All right. Everybody with us so far? And it's okay if you've moved past us or if you need a little assistance sometime, just let us know. Do you have a question? No? Okay. Feel free to move faster. It's a lot harder to kind of guide you through this and keep up. So if you move past me, no problem at all. All right, so we are going to open the PuTTY client, and we're going to SSH into the edge node O2A. So we can scroll down to find edge node O2A, and notice there is an O2B as well. That is for the secondary site that we would use in Federation. So make sure you select the O2A edge node. And you can click load and open, or you can just double click it. Both accomplish essentially the same thing. It may pop up and ask you to accept the security alert. If it doesn't, no big deal. We can just skip that. And mine actually logged in right away as well. Sometimes it will prompt you for a password. All right, so we are going to take a look at the existing logical routers on this instance. So we want to type the command get space logical dash routers. And that, you know what, I should have asked you to maximize this because it's just not a great view without it. So I'm going to type that again so that it prints out a little better. And now you'll notice on this super blurry screen up here that we have these VRF IDs. And you'll see what they're related to. Over here, we've got, this is the service router for our T0, and this is the distributed router for our T0. So we've got VRF 1 and VRF 3. What we've been configuring would be the uplinks, and those are going to be tied to the service router. So on the next step, we're going to see that we want to enter the VRF instance. So you're going to type VRF space the number 1. You should see the VRF number 1 listed beside service router T0. Then we're going to take a look at the BGP configuration. So get space BGP space neighbor, and all of this is tab complete. I forgot to mention that. So if you get enough unique characters, just like most other CLIs, you can tab complete, and we want get BGP neighbor summary. So you can see there we have our BGP neighbor 168.120.1 with an AS number of 65002. Oh, and I forgot to mention the state. The state is established. That's exactly what we want to see. So let's go back over to the browser. And we're doing a lot of bouncing back and forth because there are different pieces of information you can see from different tools. Most of it is available in any one interface. We just want you to understand that you can get to it in multiple locations. So if we take a look at this network topology again, notice that we now have 2 uplinks on the top here. Before we only had a single uplink heading out of that T0 gateway. We now have 2. And again, you can zoom in on that area. You can do whatever you'd like to gather additional details. You can see when you zoom in, you start to see an IP address. This particular router is now configured for multiple uplinks, multiple paths out. So we have the equal cost multipathing configured. All right. So the next thing we're going to do is configure bidirectional forwarding detection. So we're going to go back to the T0 gateways and edit that T0 gateway 01. A lot of numbers and acronyms here, I know, I apologize. We're going to scroll all the way down to BGP. Expand that, and we are going to click on the BGP neighbor number 1 again. And click the 3 dots to go to edit. And we're going to, where's the toggle? There it is. Sorry, I scrolled too quickly. Right here, this toggle right at the kind of center left of the screen, BFD, currently is disabled. We're just going to click that. It'll slide over and set it to enabled. We also have to adjust the timers. Because we're in a nested environment, we do not want to have essentially a false issue. So we're going to adjust the BFD interval to 1,000 instead of 500 milliseconds. Then we'll click Save and Close. Close editing so that it doesn't yell at you. If you happen to move away from the screen while you have that editing window open, it'll just ask you kind of a warning. Have you saved all your changes? Joe, got a gentleman with a question. All right. So we're going to simulate the failure of an edge node so that we can see how this traffic path, the traffic pattern will change. So we can go back over to our existing terminal. If you closed it, no problem. Just open a new terminal. And we're going to start a ping to Web01A. That is... make sure you ping what's in the command section because I messed up already. Notice the different FQDN. This is the correct FQDN. This one is not. So note for later, I have to fix that. So we want to ping web01a.corp, oops, too many dots, corp.vmbeans.com. And there we go. We're receiving a response. All right, we can end that. Or if you did it the right way, you probably did the -4, which I did not do, so it just keeps going. And then we're going to do a trace path again to a different address now. Trace path -n for that same Web01 machine. I just cannot type today. And there we go. We see the hop. We went through the 120.4 network. So the 120.4 address is the one we just added to the T0. So we've already taken advantage of that secondary path. So now we are going to simulate a failure to that. If you go back over to your Firefox browser, we can launch a new tab. Go ahead and log into VCSA 01. This will take me just a moment.
And I guess if anyone has any questions, this is probably a good time to ask them.
You know what? I did not log out of... No, I didn't log in with my own user account. So someone else just logged in with their user account somewhere else and kicked me out. Super secret password here. Let me just check to make sure. Yeah, no enrollments. Okay. So I will 24, 25. This will take just a moment for me to get this back up and running. I'll burn through the previous steps pretty quickly while I catch up here. Just an FYI, I forgot to mention, up here you see the table of contents way up here in the upper right corner off the screen. So if you click that, you can actually jump to anywhere in our lab manual. So I know that we had already configured, or we were in the process of configuring and testing bidirectional forwarding and detection. So we were in the process of our trace path. So it lets me go right to the step where I need to be. It'll take me just a moment here to get this fired back up. And again, feel free to work ahead of me if you're able to. Not a problem. I will do my best to catch up. So the passwords for most of these are populated automatically, but one of the things that I have noticed is that sometimes it doesn't, notice how I'm clicking here, the password's there, but it's not populating the login. If you just hit enter instead, it'll log you in. Just one of the little intricacies when you nest all this stuff under each other, sometimes they don't work the same way that they do in your environment. All right, so I'm gonna hit this T0 real quick and add the interface. And I'm going to do a little bit of a cheat from where I have the manual written. I'm going to add the interface and configure the BGP and add the BFD all together so that I can catch up as quickly as possible. All right, I am adding the other BGP source address. And while I'm in here, I'm just going to tick that little box for BFD and adjust the timer to 1000. All right, so now I'm going to confirm, since I did several steps at one time, I'm going to confirm to make sure that my BGP peer, the status is happy. It is. And that my configuration is correct. All right. Terminal to do a trace path. Oops, I typed the, out of habit, corp.vmbeans.com. And there we go. Okay, so I'm back to where I should have been 5 minutes ago. Sorry about that. 120.4 is the path I am currently taking. So if we go back over to the vCenter tab, you may have already completed these steps. We are going to log into vCenter and find the edge node. They want us to simulate or to start a ping to web-01a .corp.vmbeans.com. And there we go. We've got that ping going. Back over in vCenter, we're going to find the region A01, edge 01. And that's down here in this cluster. And we're looking for edge node 02A, this guy right here. If we right-click it and go to Edit Settings, we're actually going to disable or disconnect the NICs, both of them, to simulate a failure of all communication to this edge. This could be that the edge itself has failed, the host has failed, and the edge is going through an HA to another host, whatever the case may be. And if we go back over, that was actually super fast. We actually did not see a single ping drop. Sometimes you will see the loss of communication here as it's doing its failover process. But it looks like we didn't drop a single ping, which is great. I like that example way better than the several pings that I lost during my manual building. So if I stop this ping, hitting Control-C, we can do another trace path. And now notice that we are going through 120.3, which was the original uplink that was configured as part of our base pod. So the traffic has failed over. In this particular instance, we didn't even notice a single ping drop. It just detected it, popped it over there. It happened so quickly that we couldn't get a ping there in time. So that shows how quickly it can reconverge. Sometimes it's going to take a little longer, depends on your particular environment. There are a lot of factors that will determine how quickly that can recover. All right, let's go back in to edit the edge and bring those interfaces back online. Put a checkbox in both of them for connected. Click OK. All right. Any questions on ECMP, BFD, all of that we've gone through so far? Good? All right. So the next topic is virtual routing and forwarding, VRF. That's what I've always heard it referred to as. This allows us to have a single T0 that acts as the parent, and we can have multiple routing instances that are tied to that T0, multiple VRFs. So we're going to go through a configuration of one of those VRFs. The manual, you're able to start anywhere in this lab that you want, so we do kind of assume that you're basically starting from scratch. So you'll see that it wants you to launch the browser, wants you to log in, all of that stuff. If you're already in, great, don't have to worry about any of that. So we're going to switch back over to the NSX interface, user interface, and we're going to go to segments. And we will be adding a new segment. So we can click Add Segment. And the segment name will be VRF-uplink. We do not want this connected to a gateway because this is going to be a VLAN-backed segment, not an overlay segment. So we will find our VLAN-TZ transport zone, and then we will add the VLAN for this particular segment, which is VLAN 131. All right, scroll down just a little and click Save. And we do not have to edit anything else on this particular segment, so we can click No. Our next step is going to be to actually create the VRF instance. So we'll go back to the T0 gateways in the left column. And at the top, you'll notice there's a little down-facing caret on Add Gateway. If you click that, you'll be presented with the option to click or to create either a T0 or a VRF. In this case, we're going to be creating a VRF. And our VRF is named VRF-GW for Gateway-01. And we want to tie this to the existing T0 Gateway 01. So any new VRF must be tied to an existing T0. We can scroll down and click Save. And we do want to continue configuration on this VRF. So when you get this prompt, you'll click Yes. We want to add an interface. All right, once you're under the set interfaces, click Add Interface, and this is going to be VRF-uplink. And the IP address is 192.168.131.3/24. We want to tie this to that new segment that we just created, the VRF uplink segment. Notice that we had VLAN 131, and 131 is the third octet of our IP space. Now we also need to tie this to a particular edge node. In this case, we're going to select edge node 01A. Then we can scroll down and click Save. All right, now we can close that window. And we want to configure BGP on this edge, or I'm sorry, on this VRF. So we'll scroll down just a touch and expand BGP and click Set beside BGP neighbors. Once you're there, you can click Add BGP neighbor. And our new neighbor is 192.168.131.1. We are not going to be enabling BFD on this particular instance. The remote AS number is 65100. And our source IP is that interface that we just created, the 131.3. So if you scroll down just a touch, you'll find the Save button. Click Save, and then click Close. So now that we've got our neighbor configured, we can actually turn on the slider for BGP and click Save. So BGP is now enabled. We have a neighbor configured. We do have ECMP enabled, but since we only have a single uplink, it's not doing anything at the moment, but it is enabled if we added a second uplink. All right, now we can go back over to PuTTY. If you already have a session open, you'll have to either close the session, or you can right-click PuTTY and go to New Window. And we want to connect to edge node 01A. Oh, yeah, edge node 01A. Sorry about that. Again, maximize this window. It'll just make it easier for you to view the screen. Enter the password if you are prompted. If not, no big deal. And what we're looking for, we're going to do a get space, oops, my mouse wasn't in there. We're going to do a get space logical routers. Logical dash router. And we're looking for the service router for our VRF. So notice in the middle of the screen you see SR, which stands for service router, dash VRF, a lot of VRF there, gateway 01. So SR, again, stands for service router. The first VRF is NSX telling you that this is a VRF. The second one is actually what we called our router. So if we'd have called it something else, it wouldn't be VRF-first, it'd be VRF-whatever you called it. And a little less confusing than what I chose to put here. All right, so we want to enter that particular VRF by typing VRF space 4 in my case. If your number is a little different, which it's possible, things come up in different orders, so your number may be different than what I have on my screen. But I have VRF 4 here, and then we're going to do another get space BGP, if I can type, BGP, neighbor, summary. And again, tab complete is your friend. As you can tell, I'm not very good at typing, so I make mistakes all the time. I usually get just enough unique in there so that I can tab complete, and we can take a look at this. So again, we have our remote AS, or our remote neighbor is 131.1, our AS number of 65100, and we have established. It's been established for about 2 minutes and 20 seconds. That's exactly what we want to see. Was everyone able to get an established BGP? Great, great. Any questions so far? Awesome. Okay, so let's take a look at the routing table for this particular VRF. Actually, I think we're going to take a look at the T0 routing table first. So we're going to exit out of VRF 4. and do get logical routers again if you want. I can actually still see the previous command here on my screen. So I know that the SRT0 gateway is actually VERF1 because it's displayed there. And notice in the manual example, it is VERF2 is what was displayed. So in my case, it's VERF1. I want to make sure I put the correct VERF in there. And then I'm just going to type get route. So this will list out all the routes that are either learned or directly connected to the base T0. And if we notice, we can look through here. I see a couple of 192 networks at the bottom, but they're all 120 or 220. We do not see the 131 network. And again, that's because it is on that separate virtual routing instance, the separate VERF, and we are not currently sharing any information between those VERFs. All right. So what we're going to do next is, a lot of times it's called route leaking. We call it local inter-VERF routing. So between our T0 gateway 01 and our VERF gateway 01, right now, we cannot talk between those. They can talk out, they can do all of that, but they don't know that each other really exists. So we're going to attach a couple of networks and actually go through that process and show how you can create a static route that will allow that traffic to actually traverse. So again, this is assuming that you're starting fresh at this point. Just go back to your NSX interface if you're already logged in. Fantastic. We're going to go to T0 gateway 0. Oops, I didn't close editing. We'll fix that. There we go. All right, so under T0 or under tier 0 gateways, we're going to go to the T0 gateway 01, expand it, and if we scroll down to routing, we'll see that we currently have 0 static routes. We're also going to take a look at the VERF gateway and see that we have 0 static routes. So we have no static routes currently enabled. Makes sense, we just looked at the routing table and nothing is being shared. Next, we are going to create a T1. So if we click on T1, Tier 1 gateways in the left column, and then add Tier 1 gateway. Ooh, I see another typo. That should be VRF, not VRK. So VRF-T1-GW for gateway 01. And we want to link this. In this case, we want to link it to the VERF gateway 01. And we want to tie it to edge node or edge cluster 01A. Scroll down just a touch and click save. We do want to continue the configuration on this particular network, so feel free to say yes. All right, so what we're doing here is we're changing the route advertisement. So notice we have the route advertisement section here. If you click that little caret to expand it, we want to make sure that all connected segments is highlighted. Currently, it's only all IPsec local segments, and that's fine. We can leave that on. We're not actually using that in this particular lab, but that can stay on. What's really important is we're going to connect a segment to this, and if we do not turn this slider on, then that segment remains local. This T1 will not advertise that segment up, so therefore nothing else will ever be able to route into it. So let's click save on the segment, or on the T1, and scroll down and click close editing. All right, we are going to add another T1 gateway. So here it is going to be called T1-GW-01. And this one is going to actually get connected to the root T0. And again, assign it to edge cluster 01A. So one thing that we didn't really cover in this particular lab, it's covered in the -01, is you can have a single root T0 per edge cluster. But you can have multiple multiple T1s and multiple VRFs in a single edge cluster. So that's why we keep selecting edge cluster 01A. All right, go ahead and save that. And we do want to continue configuration for the same reason. We're going to enable that all connected segments under route advertisement. We want to make sure that anything we connect to this gets advertised up through the T0. So tick that little slider and click Save, and then close editing. All right, so what we've just done is we've created T1s, we've enabled the route redistribution on the T1s, but they're connected to another router, our T0 router, both the VRF and the root T0. They also have to be aware that you're trying to share additional routes. So what we're going to do next is we're going to edit those T0s. So click on T0 gateways in the left column and find the top one there, T0 gateway 01, and click Edit. Oops. Route redistribution is way down here. And notice there's a number 1 right here beside route redistribution. If we click on that, we'll see that currently this is set to connected and static. We can click this number 2 and see that means just connected and static on T0. There are no advertised T1 segments or subnets. So we want to actually add a segment. So if we add, I did this a little differently than what my manual says. I apologize. If you followed the manual, you'll see an edit at the top here. If you listen to me, I'm sorry. You can click Add Route Redistribution here. And then we are going to add one that is called T1 Connected. I'm betting you can guess what we're going to add to this. If you click Set, you'll see under Advertised T1 subnets, Tier 1 subnets, you have Connected Interfaces and Segments. And when you check that, it will automatically check the Service Interface subnet and Connected Segments. That's exactly what we want. So go ahead and click Apply. And then click the Add button. And finally, apply again. I don't know why I said finally, because there are a couple more steps. Save, and then close editing to close the T0 Gateway 01 editing window. Now we're going to rinse and repeat, do the exact same thing on the VRF gateway. Again, because yes, we're advertising from the T1, now we need to make sure that the T0s will also advertise those networks. So again, scroll down to, oops, I clicked the wrong thing. Route redistribution down here at the bottom. Click Set, and notice we have no redistribution rules here. It's because we just created it. We need to actually establish one. So we are going to add a new route redistribution to this, and it is going to also be called T1 Connected. Click Set to reach in there and tick that little checkbox for Connected Interface and Segments. Apply, add, apply, save, close editing. Yeah, there are a lot of clicks. All right. So now we have set it up so that all of our routes from either T1 will be distributed back up to the T0. But we've not yet done anything to make the T0 and the VRF talk to each other. So what we're going to do is we're going to create a segment and attach it so that we can actually have a VM workload that we can test with. So on the left-hand column, click Segments, and then Add Segment. And we're going to create a segment called LSDB for database. ls-db. We're going to connect this to T1 Gateway 01, which is this guy right here. We want the transport zone to be the overlay transport zone. And the subnet 172.16.30.1/24. All right, scroll down and click Save. We do not have to continue editing on this. We've already set everything that we need. So we're going to create another segment called LS-VRF. LS-VRF. I'm guessing you can figure out where we're going to connect this one to the VRF T1 gateway. Again, we're going to put this in the overlay transport zone. And for this, we're going to use the network 172.16.100.1/24. Scroll down to save, and no for continue editing. All right, everyone with me so far? Any questions? Good. Okay, so we'll go back over to the vSphere client, and we're going to be looking for a virtual machine called DB01A. It's under the upper cluster under Region A, Comp 01. If we click on that VM, you can either right-click it or you can go to the top and select Actions, but what we want to do is Edit Settings. And you'll notice this is currently, the network adapter 1 is currently set to VDS-comp. We want to change that. We want to connect this to the LSDB network. All right, so we should now see an IP address here of 172.16.30.11. That should be on the segment that we created for LSDB. So if we go over and open PuTTY, we want to connect to DB01A. You should be able to scroll down and find that in the list. Again, you can double click it, you can click load and then connect. Totally up to you how you get to it. All right, let's go ahead and maximize, again, to make sure that things just display a little better. And we want to ping a couple addresses. So first, let's ping our gateway. Oops, I did it again, typing 168. So 172.16.30.1, and we get a reply. That's exactly what we want to see. So now let's try pinging 172.16.100.1. We do not get a reply. That's what we expect. We should not get a reply from that because we haven't actually established the route leaking, the inter-VRF routing. All right. So we want to open a new window, and if you right-click on the PuTTY icon in the taskbar, you can select New Window. And we're looking to open Edge 01A. All right. Again, let's maximize this so that we can see better what's going on. Get space logical dash routers. Again, tab complete is your friend, especially for those mistake prone like I am. And in this case, we're looking for the SR for the VRF Gateway 01. And that is, it's a number 4, VRF 4 in my instance. The manual says VRF 6 because that's what it was when the manual was built, but be sure to replace the number in the manual with the number that you actually see on your screen. So we're going to go VRF 4 for SR VRF VRF Gateway 01. All right, so once you're in there, we're going to do get interfaces. And again, this is tab complete. And you can scroll to find the particular interface that you're looking for. So usually this is pretty close to the top. So almost all the way up. It takes a while to get there. You'll find one that's called, what is it called? It'll be the T1 LRP, Logical Router Port. And in my case, it is not at the top. Takes a moment to find this. There it is. It was the top of the second section. My bad. So we have a VRF Gateway 01. It's a really long name, but oh, that's the T0 logical router port. Sorry, that is the wrong one. Okay, what am I doing wrong? That's under the DR. You know what? There's an easier way to pull this up. I tried to show the long way around. Let's go to the UI. Because if you go back to the NSX UI, under the network topology, you can actually view this. We're on the VRF, so let's zoom in. Oops. All right, see this address right here? This 100.64.0.1. That is the interface that we want. And notice, that's what my documentation says. So this is the much easier way to do it. I just like to show you the hard stuff too. So we want to make a note of that particular address, 100.64.0.1. And we're going to add a static route that actually references that address. So if you go back over to the T0 gateways in the left-hand column, we're going to find T0 gateway 01 and click Edit. And then scroll down under Routing. You'll find that static routes that we saw earlier that was empty. We're going to click Set. Let's add a static route. And what we're looking, we can name this pretty much whatever we want, but I have it named as ls-vrf-static-route because I'm -VV for very verbose. Okay, so the network is going to be the 172.16.100.0/24 because we want the network address here, not a particular gateway. And then we're going to click Set for next hops. And this is where we're going to use that 100.64 address. So click Set Next Hops, and we want that to be the 100.64.0.1. And we're going to set the scope to VRF Gateway 01. There it is. Click Add, and then Apply. Okay, so apparently we took way too long. We didn't even get through Module 1. That's my fault.
An hour, basically, and it died?
If you have a button to extend, if you have a button at the top of the screen to extend, please click Extend. Yeah. It's a 90-minute session. Well, apparently I was super slow. I apologize. I should have gotten us through way more of this. So hopefully you haven't all timed out. I went ahead and clicked Save here. We can now close and close editing on this particular VRF, or on this particular router. We're going to go back over to the network topology because that was far easier than the CLI. And if we zoom in here, we see this one is 100.64.0.3. So that's what we're going to configure. We go back over to T0 gateways. And this time we're going to edit the VRF T0. Oops, I think I did it wrong anyway. No, I have it right. I might have another typo in Yeah, ignore my instructions here because my heading says add static route to the VRF, and then my instructions say to T0 gateway 01. We want to add this to the VRF. We haven't added one there yet. So expand routing, static routes. All right, our static route is ls-db-static-route, again, with the network of 172.16.30.0/24. Again, the network address, not a gateway. And we're going to set the next hops. So the next hop IP was 100. Oops, my mouse isn't in the cursor. 100.64.0.3 as our next hop with the scope of T0 gateway 01. Click add, apply, close. Oops, I forgot to click save again. Save and then close, and close. All right, so now we can go back over to our PuTTY session if it's still open for DB01A. If it is not, feel free to relaunch. And we want to try that ping to the 100.1 again. You can try both of them if you'd like. 30.1 should already work. Let's ping 100.1. And there we go. So what we've done is configured route leaking by adding static routes to each one of the VRFs using the internal routing interfaces. The 100.64 interfaces are actually internal to the T0. It's how it communicates down to your T1s. So that is why we use that particular interface. You can also do non-local route leaking by leaking back up through your physical infrastructure. Everything's small here. We only had the one vPod router. If we had another, we could have done it that way. Any questions? So since we're running out of time with the labs, I apologize for that. I don't know why that's happening. We definitely have a lot more to this. Is there anything that you'd like to see us walk through? I still have some time on here. You might not be able to follow along, but something that you might want to see out of the topics that we mentioned. Federation? Okay. Yeah, absolutely. So let me move over to the table of contents here, and I will bump down to Federation. So Federation is a fairly intense module as well. There's a lot going on there, so we won't be able to get through a lot of it, but we'll step through adding a site, importing the contents of that site. Let's see what we can. I'm going to skip through some of the early on pieces of information here. I highly recommend, especially if you're interested in the Federation, to take a look at how these architectures are set up. The two sites and the infrastructure that's actually at both sites it's pretty interesting. It's definitely a key piece of information to understand that leads to the decisions that we make within this lab. All right, so again, we want to fire up a browser. We are going to launch the California 3-tier app, and we want to select CA Web 01. And notice that the application popped right up. That's exactly what we want. So CA, anything that's labeled CA is technically at our site B. Everything we've been doing so far has been at site A. That's where most of this lab takes place, but we wanted to simulate multiple sites, and that would be the California location. So we know that this loaded up. You can see which server it actually connected to, CA Web 01. If you want to, you can go to CA Web 02 and see that we are now accessing there. You can do a filter in here if you'd like, tinker with it however you'd like to. All right, we're going to do a Postman to do a little bit of cleanup. So go ahead and launch Postman. Takes just a moment for the client to load. Is everyone familiar with what Postman does, like how useful it can be? Just a quick description. Postman is an easy way, a GUI, a graphical user interface way of executing API calls against an endpoint. I use it daily, probably hourly. I live in APIs. I love this stuff. So Postman is a critical tool. What we're going to do is we're going to take a look at Module 6 here and click the 3 dots beside Module 6 and select Run Collection. Actually, if you did get kicked out, you may be able to restart and actually start this module. So if your lab has timed out, go ahead and try to get back in. If so, you can jump right into Module 6 where we are and join in. All right, so we selected the 3 dots beside Module 6 and Run Module. So what this does is it's grouped together multiple API calls. And again, this is all about cleanup. We had this set up in a way where the application is functional. We're now going to break that. We're going to tear it down. This is, the first one is going to delete the segment for LSCADB. The next one is the app. The third one is the web. And then the final one actually deletes the T0, the Tier 0 gateway that is on the Site B location. So we'll click Run, and it's going to actually go through all 4 of those API calls quickly, one after another. So we have now completed that. And if we were to go look, I should have shown you first what it looked like, but in Region B NSX Manager, we can log in using the admin. Takes just a moment, and we will now see we have no Tier 0 gateways. There would have been one there had I thought to show you first. Sorry about that. All right, so we have a 200 OK. Everything has completed. If we go back to the database tab here and actually click refresh, it's not going to load. We just ripped the networking out from underneath this application. So notice it's just hanging. Now we can't find it. All right, let's log into the Site A. Sorry, I have to remember where this is at. So we're going to log into the Site A NSX Manager. So again, launch a new tab, click Region A, NSX Manager A01 or NSX Manager 01A, and then log in. We're going to take a look at the edge clusters. So under System, and then on the left-hand column, Fabric, Nodes, we will see a heading for edge clusters. Okay, we're going to continue to the next step to create a new edge cluster. And here we will call this Fed Edge Cluster for Federation. You can put a description in there if you'd like. I'm not going to for, well, I'm pretty slow today, so we'll do whatever we can to keep going. All right, check both O3A and O4A. Oops, you know what? I did that wrong. Don't do what I did. I forgot to move them. So you want to check them both. I forgot to move them over. I do that all the time. So make sure that they get moved over into selected and then click save. Or add if you were already at that step. All right, so now we're going to go to the NSX Manager appliance, right up here, appliances. And we're going to pull the information for this NSX Manager. What we're looking for is actually the thumbprint for the certificate. So when you look at the NSX Manager here, you'll click View Details. And way over here to the right, see Cert Thumbprint. You can actually just click this copy, and it'll put it on your clipboard. So it's ready for us to use. All right, Now we have to log into one more NSX manager. So if you click the plus, we're actually going to log into the global manager. This is the NSX manager that is going to manage all of the environments. In this case, two, Site A and Site B, but you can have more than two. So if we go to region A and select NSX G MGR instead of just NSX MGR, we will be able to log in here, again, using the admin account. It should populate, but the password is VMware1bang, VMware1bang. Once this loads, we're going to go to System, and then Location Manager on the left. Notice we have some different options here than what we do in the normal NSX Manager. Location Manager is part of the Global Manager. You will not see that unless you're in Global Manager. And then we're going to see right down here at the bottom of the screen, Add On-Prem Location. So here we want to fill out some information. We're going to add the Site A location. So, location name, Site-A, NSX, wow, I cannot type, MGR-01A.corp.vmbeans.com. Again, admin, and it may auto-populate the password, VMware1bang, VMware1bang. And right here in this box, this is where we want to paste what we've got copied to our clipboard. So you can right-click and select paste. You can hit Control-V, whatever works for you. But this is the thumbprint of the Site A NSX Manager. This is actually how it's going to validate that it is connecting to the correct thing, to the correct manager. We're going to click the button for Check Version Compatibility. It's going to reach out and make sure that we're on a compatible version. Imagine that. So we're at 4.1.0.2. We can now click Save, and this is going to take just a moment. I would say this takes anywhere from 30 to 60 seconds for a very small environment. It could take 5 minutes if you had a lot of resources already in an NSX Manager, because it's reaching out, it's gathering information about that environment, it's pulling back a potential inventory so that it can track that and have that available for some of the steps that are coming up. You'll notice down here we are connecting. If you see there's a little refresh, and I apologize, I forgot, this is super blurry. So this is way down here. Now I have clicked that tiny little refresh button and I am green with success. So we're going to take a look at Site B again. If you opened a tab for Site B like I did, you can go back to that tab. If you have not, launch a new one and find the bookmark under Region B NSX Manager 01B. Log in like you do any other NSX Manager here, and we're going to go to System, Appliances. We're doing the exact same thing. We're grabbing that certificate thumbprint. So under the appliance, we'll click View Details and copy that thumbprint. We can close the thumbprint window and we'll move back over to the Global Manager, which in my case is my final tab here. Just make sure you go back to your Global Manager tab. We should still be on Location Manager. We can now click Add On-Prem Location, type in this case, Site-B with the super unique FQDN of NSX MGR-01B.corp.vmbeans.com. And again, it may have the password and username saved. If not, VMware1bang, VMware1bang. And we're going to paste this thumbprint in here again. One more time, we're going to check version compatibility. That one came back really fast. We are at the same version. Imagine that. Let's click Save. This one will likely finish a little quicker because we have fewer resources in this Site B than we do in Site A. Again, 30 to 60 seconds for our tiny little lab here. In a larger environment, it may take as many as 5 minutes. All right, I'm going to scroll down and click refresh. Look at that, we've got success. And you can see here, we did put a note in here. After saving, it can take 2 to 5 minutes. In here, it's pretty fast, but in a real world, it could take a little bit of time. So what we want to do is we want to import some objects here. So under Site A, oops, did I miss a step? I'm not getting that. Give me just a second here. All right, let me refresh this, see if we've got a default transport zone yet. Is anyone else getting this, this error message that a default transport zone wasn't found? Joe, are you seeing this default transport zone not found on anyone else?
It's fine. It goes away after a while.
Okay, so it's just pulling in the inventory.
Yeah.
Yeah.
They'll go away.
So it'll take, just like I said, after saving, it can take between 2 and 5 minutes for everything to be up. So we'll give it just a few moments here and keep refreshing the page. So the next step we're going to do is actually import the components that are at the different sites. So we just have to wait a little bit longer. And we can see actually Site B, since it had way less infrastructure, is already to the point where it's ready for import. So we'll just do these a little out of order. Let me make sure that, yeah, we're just going to do them slightly out of order. While we wait for Site A, we're going to import Site B. Yes, we want to proceed to import. All right, so we're importing Site B. Let's put a prefix on everything of Site-B-. And next. And you can see here it's going to pull in one security group, 9 security policies, and 2 networks. We can click import, and this will take just a few moments. And that is actually working in the background here. Let's refresh this page again. I'm going to refresh the whole page. Let's see if Site A is ready for import. Nope, Site A is still doing its thing. So again, a few minutes. Again, the difference is the amount of infrastructure. We deleted all the infrastructure at Site B at the start of this module, so there was very little for us to bring in. Site A has the T0s, the VRFs, all the segments that we've already dealt with, the VMs that are attached to them. So there's just a lot more there for it to pull in. All right, looks like our import of Site B has already completed. Let's see if we can get Site A. Nope, not quite ready. How much time do I have? 3 minutes. Okay. We might not be able to finish this. Let's see if there's anything else we can do after the import. Yeah, the next step is configuring the RTEPs. So we briefly touched on the TEPs, the tunnel endpoints, early on. The great thing about Federation is it doesn't actually require jumbo frames between your sites. We use something called RTEPs, which allows you to actually have your remote sites connected via the internet and not have to rely on whatever internet connectivity is out there supporting anything over 1,500 bytes for the jumbo frame, because most ISPs are not going to do that for you. So the RTEPs will actually fragment the packets and put them back together without the source or the destination ever knowing that occurs. But that's kind of the next step here. I'm not sure that we're going to be able to finish that. Let's see if we can even get started. Nope, not quite yet. So with the last minute that we have, does anyone have any questions? Yeah. Give me just a second. Great question. So the question is, with the RTEPs, if it's going over an IPsec tunnel, would you have to lower it down? So if your IPsec tunnel is adding additional overhead onto the packet, the answer would be yes, because the RTEP is expecting to be able to take advantage of the full 1500 MTU. If it can't, we have to adjust that to accommodate for it. No, fragmentation, when we're encapsulating like this, unexpected fragmentation is bad. Will it fragment at all, Jen? Do you know?
There's no MTU requirement between the RTEPs.
I thought it had to be 1500. So if it was going through a tunnel, like if he's adding encapsulation for IPsec on top, that would drop it down to 1472. So if someone tried to send a 1500 MTU, would it? I can get you an answer on that. We've got a lot of smart people here, way smarter than I am. She's definitely one of them, but you're kind of putting us on the spot, so I apologize. Let me get an answer for you on that. That's a very, very good question. Any other questions? Awesome. Well, I apologize. We ran into a couple of hiccups, but you guys really stuck it out with us. I really appreciate your time. Hopefully you enjoyed the lab. We didn't get through nearly as much as I wanted to, so please feel free to join it out there. Snag myself or Joe or Jason or any of us, and we'll be happy to help you through this. Really try out some of the other labs. I'm really proud of the automation lab, because I geek out on that. But yeah, let us know. Also, there is a survey that, if you could please fill that out, let us know. If we did a great job, an awful job, doesn't matter. Any feedback is good feedback. We want to know what we can do to improve this for next year or later, even when we can make updates. So thank you very much for your time. I really appreciate it.